I see you have taken the punishment of 14.1, you've come back for more. So, kudos. Now we're adding and subtracting fractions, which everybody, man, we did this back in elementary school. We can do this again. Bottom line is denominators must be the same. Okay? You're still going to have to do all the kind of important stuff like factoring, but once you've got everything factored, denominators must be the same. All right? So in order to get them all the same, you really just, again, you have to look at it in factored form and then determine the least common multiple for your denominators. And I'll just, honestly, you can pause and copy stuff down here if you need to. I'm just going to go jump into some examples now. Okay, so, oh look, denominators are not the same, therefore I need to find the least common multiple for my denominators, and I'm going to have to factor them. Looking around, the only thing that appears to be factorable is this denominator down over here, so I'm going to factor that. The top is still x minus 1, but then this bottom would become, it looks like it multiplies to 2 and adds to 3. That would be x plus 2 and x plus 1. So I factored that denominator, and I'm adding x over x plus 1. All right, so step 1, I had to factor. Now I determine the least common multiple among the denominators. You want to look at what they have in common and what they don't have in common. So, for example, right here, x plus 2 and x plus 1 are those factors, and just x plus 1 is this other factor. So clearly, they have an x plus 1 in common. What do they not have in common? The x plus 2. Now, which fraction needs that so that they both have it in common? They need to have every factor possible in common. Well, I don't need to multiply anything on this first fraction because it already it's got both of them. It's got both of all the possible factors. It's got both of them. But this other fraction, it needs the x plus 2. So I'm going to multiply that, both top and bottom, times x plus 2 over x plus 2. In doing so, this will make both fractions have the same common denominator. So now on the left, again, I'm not changing anything on that left fraction, so that's still x minus 1 over x plus 2 times x plus 1. Plus, now I'm multiplying x times x plus 2, and on the bottom here I also have the same denominator. Doesn't matter which way you write it, they're the same factors, x plus 2, x plus 1. Okay, now that my denominators are the same, I can add straight across the top. I don't do anything to the bottom. The bottom, when you're adding and subtracting, does not change anymore. The only time you change it is to make it match. Once it matches, it does not change. Denominator does not change now. So the denominator is still x plus 2, times x plus 1. But on top, I'm going to add these two things together. Well, I've got to multiply x times the x plus 2, which is x squared. Okay, there's no other x squareds to combine along the top, so I do have an x squared as one of my terms. And then multiplying x times 2 is 2x. Now 2x I can combine with 1x to make 3x. And then there's no like term for this minus 1, so I'll just leave that right here. Now, the last thing to do would be to factor the top, but as I look at the top, it's not factorable. So then this is the answer. And we're done with that one. Oh, we forgot to state what values of x would make this undefined. Remember, that's actually, after I did this red step of factoring it, that's really the next thing I should have done. So x cannot be, based on these denominators, it cannot be negative 2, and it cannot be negative 1. And I get the same thing over here, another negative 1. So really just negative 2 and negative 1. X cannot be either of those. All right. And once again, my answer is, I need to write that part, and then this is my answer. And since the top is not factorable, we're done. Okay, so once again, same kind of issue here. Let's factor the top. I can pull out the 2 and that would be an x squared minus 8. Okay, and then on the bottom would factor into, because it's a difference of squares, would factor into x plus 4 and x minus 4. I'm sorry, x plus 2. There we go. X plus 2 and x minus 2. And we have a minus, the x plus 4 is fine, and the x minus 2. Okay. So notice I do have an x squared minus 8 here, but that's not a difference of squares because 8 is not a perfect square, so that's fine as it is. Then this is as factored as we're going to get. So now I look at the denominators and I see I've got an x plus 2, an x minus 2, and over here I have an x minus 2. So they have the x minus 2 in common. What they don't have in common is the x plus 2. So actually, I guess once again, before I should multiply, I should state that x cannot be negative 2 for this first factor. It cannot be positive 2 for the second factor. And we already have the positive 2 covered there for the third fraction, or the second fraction. So we're good there. The x cannot be these. Oops. So we got that covered. And then now, like I said just a second ago, that the missing factor to make them all have everything in common is to multiply times x plus 2 on both top and bottom. Okay, it's funny, it's the same thing as the problem 1 was. All right, well, let's simplify what we've got here. I am going to have to distribute and FOIL on these so that I can combine like terms. So when I distribute on the top of this fraction, that would be 2x squared minus 16 over the x plus 2, the x minus 2, and then minus, okay, to FOIL this, and you should get x squared. I'm going to get plus 2x. I'm also going to get plus 4x, which makes plus 6x. And then I'm also going to get plus 8 there at the end. 4 times 2 is 8. So again, I just FOILed this guy times the x plus 2 to get this right here, and I went ahead and simplified that. Okay, and then the denominator is the same. All right, so then now I can subtract. When you're subtracting, the thing you just got to be paying extra attention to is that because it's a minus off all of this, I'm going to change the signs of like the 6x and the 8. So just be aware of that. Now then, 2x squared minus x squared is x squared. There is no x here, and we're minusing a positive 6x, which is going to change that to a negative 6x. Okay? And then I have negative 16, and I'm subtracting positive 8. So negative 16 minus 8 is negative 24. All right? Over x plus 2, x minus 2. Now then, is this factorable? Let me think. Things that multiply to 24 are 6 and 4. That's not going to work. 8 and 3. That's not going to work. 12 and 2. That's not going to work. So that's everything. So it looks like this top part's not factorable. So once again, we're done. We would have said then, these are the restrictions on x, and then the actual answer is this little guy right here. Most of the time, you're probably going to notice that the top, after you add or subtract, is not factorable. Most of the time. Okay, so last one here. And let's factor our denominators. So then I've got x over, I see a common factor of 2 down here, so pull out that 2. That'd be x plus 3. And then minus, I've got the x plus 3 over here. And let's see, multiplies to 9, adds to 6. That's going to be a positive 3 and a positive 3, so just x plus 3, x plus 3. All right. Now, I'm actually noticing I could go about this 2 ways, and it's kind of unique to this problem here. I'm noticing that I could cancel out this x plus 3 here and work forward from that. That would probably be the easiest way to do this. The other way is I can still just treat this like I've treated any problem, and I mean, regardless, I still have to do this part where I say, okay, x cannot be negative 3, and oh look, all the denominators are like that, so just x cannot be negative 3. So regardless, I got to do that. But then I'm noticing that, you know, like I said, I'm going to actually cancel out these x plus 3's and do it this way. But the alternative would just be to treat this exactly like any other problem and seeing that, okay, on this side, I'm going to have to multiply times x plus 3 over x plus 3. And on this side, I'd have to multiply times 2. Because those are the missing factors. But I like to make things a little bit easier. So I'm going to go ahead and cross out this and cross out this. It's going to leave me with a 1 on top. And now I still need to identify what my my common factors are and what my uncommon factors are. They both share an x plus 3, but this one has a 2 and this one doesn't. So then I'm going to multiply this side times 2 over 2. And then that'll balance them out. Okay, so then in doing that, I've got the x over 2 times x plus 3 minus 1 times 2 is 2 over multiplied, you know, again, that's just 2 times x plus 3. Same thing over on the left fraction. All right, well, the denominators are common, and I'm just subtracting. Oh, this is actually an easy subtraction problem, just x minus 2 over this, and we're done.